Hello, welcome friend. Let me start lesson number 2, that is axial force, shear force and bending moment. So let me take one example, one beam that is pin joint at A and roller support at point B. So this beam is subjected to a UV load of F1, then vertical load, that is F2, and inclined force, that is F3. So this is the x-axis of the beam and this one is the y-axis of the beam. Let me take the cross section, that is MN, M and N. So if you just take this much portion, right, this much portion over here in B, so here there will be a reaction produced due to this pin joint, and this is your cross section MN. So from this side, if you take we just hide this portion, right, we hide this portion, so it is subjected to F1 force and F2 force, and due to this F3 force there will be a F internal force that produces in some like this direction. If you draw the free body diagram of this portion, that is A to MN section in C, let me see that here there will be a reaction, that is support reaction. This is the external force F1 and F2. At MN section there will be a moment. Suppose that internal moment produced in the beam, that is suppose Mx, and the internal force, that is suppose Fc, right? So now see, Fc as your F3 is inclined force, so it has two components, vertical and horizontal component. So it has some vertical and some horizontal force, right? So it has two components. So that we saw over here, that is Fx and Fy, that is Vx, right? Suppose in the vertical direction, that is suppose Vx, and this one is suppose Fx, right? So now this is the free body diagram that we are showing the internal forces produced at the section M and N, that is Mx, Fx and Vx. So let me see some sign conversion of the axial force, shear force and bending moment. So let me see that how it fix. So suppose if there is an tension force, then we take it as a positive. If you take the cross section, right, within the beam, so if in the left hand side, so this is the left hand side, so in left hand side if you have the upward force, and in right hand side if you have the downward force, then that force is taken as a positive force. If in the beam, if you take the cross section and in left hand side, suppose you see the downward force, this is downward force and this one is the upward force in right hand side, then it is taken as a negative. So if you have the compressive force, then we take it as a negative force. Let me take the cross section in the beam, and if you see in the left hand side, so this is the left hand side, this one is the left hand side and this one is the right hand side. So in left hand side if you have the clockwise moment, and in right hand side if you have the anti-clockwise moment, then your beam is subjected to sagging moment, right? Similarly, in left hand side if you have the anti-clockwise moment, and right hand side if you have the clockwise moment, then that moment is known as the hogging moment. So sagging moment is taken as a positive and hogging moment is taken as a negative moment. Now let me understand it by the example. Suppose we have the beam AB, which is pin joint at A and roller support at B, and it is subjected to a point load P at distance of A from A, and distance from B support is suppose small b. So let me draw the free body diagram of the said beam. So as it is A is a pin joint, So it is subjected to two forces. One is vertical reaction and another horizontal reaction. Suppose vertical reaction is Ay and horizontal reaction suppose Ax. Similarly, this B point is a roller support, so it is subjected to a vertical reaction, that is suppose By, right, because it is in the y direction. So as we know that we have the equilibrium condition. So we have the equilibrium condition, that is sigma fx. It means the resultant algebraic sum of horizontal force is 0. Fy sigma y, that is algebraic sum of vertical force, is equal to 0, and sigma m is equal to 0, that is the algebraic sum of moment in the beam is equal to 0. So if we just see the sigma fx, it means we sum out the horizontal force, right, algebraic sum of horizontal force. So let me see the figure. So we have only one horizontal force, that is Ax, right, and we don't have any kind of the force opposite to that Ax. So the summation of horizontal force, that is Ax, is equal to 0, right. Then we take sigma y is equal to, it means we sum the algebraic sum of vertical force. So let me see the vertical force. So we have Ay and By, that is going upward, where P is going downward, right. So let me take Ay and By, which are going upward, we take it as a positive and P as a negative, right. So algebraic sum of Ay plus By minus P is equal to 0, means this force is, the Ay is going upward, again By is going upward, where your P is going downward, right. So that's why we take it as a negative, right. So Ay plus By minus P is equal to 0, it means Ay plus By is equal to P, right. Then we take the moment, that is algebraic sum of moment at any point. Let me take the moment at point B, right. Let me take the moment at point B. So we take the moment at point B, right, point B. Point B. So in point B, so we have the force Ay, right. So first moment, that will be the distance. We are taking the moment with respect to point B, right. We are taking the moment with respect to this point B, right. So the force Ax itself is passing through the B, so there is no moment due to Ax. Similarly, we have Ay, that is vertical force, right. So moment due to Ay at point A will be Ay into the total length, that is A plus B, right, A plus B, right. So Ay into A plus B, right. So moment, that is equal to Ay A plus B, that is moment due to your force Ay, right. Now moment due to this P force at point B, that is the distance into the force. So distance is B into P, right. So moment will be P into B, right, P into B, right. That is moment due to P force, right. So total moment at this point is Ay into A plus B and P into B. So see, this moment is, if we consider this thing, then this moment is going anti-clockwise, right, anti-clockwise, left side anti-clockwise moment. So PB will be negative as it is anti-clockwise, where A into Y will be the positive. So let me see in the next slide. So here AY into A plus B, that is positive, minus PB is equal to 0. So AY is equal to PB upon A plus B. Now if we put this value, right, put this value AY into this equation, right, over here, right, over here, so you will get the by is equal to P upon A 1 plus B. Now as we taken the we need to find out the shear force for the said beam. So let me just see over here, we take the cross section somewhere here, right, at x distance, where x is equal to, suppose we take the cross section somewhere here, right, so this is the x, right, this distance is suppose x, right. So here x is greater than 0, but it is less than A. See, we taken the cross section over here, that is red line. So x is greater than 0 and less than A, right. So here we taken the cross section somewhere that x is greater than 0 and less than or equal to x. So as we know, we already find out the AY, that is PB upon A plus B. So we have the resultant reaction at A, that is PB upon A plus B. So when we take the cross section, we have Fx, that is internal force, Vx, that is again internal force, and internal moment, that is suppose Mx. So let me take the sum of the sigma x, sigma y and Mb, right. So suppose sigma x, that is equal to 0, because we don't have any kind of the horizontal force. Then sigma y, so when we taking the when we are finding the force, so AY is going upward, and Vx is going downward, right. So AY is positive and Vx is negative. So algebraic sum at this point is AY minus Vx, that is equal to 0. So it means Vx is equal to AY, right. So we have already that AY is equal to PB upon A plus B, that we already find out in our previous slide. So Vx is equal to PB upon A plus B, same as AY. Now we take the moment at point B, right. So AY into x, right, that is a distance, that is x distance, right. AY into x minus this moment, that is mx, right. So AY into x, that is a clockwise moment, so it is taken as positive, and this one is the anti-clockwise moment, internal moment, right, mx, moment at x, that is anti-clockwise, right. So that is negative, right. So mx is equal to PB into x upon A plus B, right. So we have the shear force, that is at the x distance, that is PB upon A plus B, and moment is PB into x upon A plus B. Now we take the cross section in such a way that this cross section, we take the cross section over here, and this one is the x. So see here, your x is greater than A, your x is greater than A and less than A plus B. So here A is greater than x and less than or equal to B, right. So let me take the summation of horizontal force Fx, that is 0, don't have the any kind of the horizontal force. Fy, that is Ay, that is going upward. See here, Ay is going upward, Similarly, your P is going downward, and your Vx is also again going downward. Your Vx is again going downward, right. So Ay, that is positive, P negative, and Vx negative. right? So ay minus p minus vx, that is equal to 0. So